And we want now to change the focus away from piracy onto the issue first of scrubber technology. And we have a considerable expert who is going to talk to us on this subject. In fact, we've got two technical presentations coming up. The first will be on scrubber technology, and the second will be on ballast water. So what we'll do is to ask Jad Mouawad, who is our speaker, from DNV Piping Systems and Pollution Prevention, a considerable expert on both of these topics, to give a presentation first on scrubber technology. We'll have a chance to ask some questions on that. Then he'll move the focus onto ballast water management, and we'll have some discussion on that as well before then going back to invite Trond to give his Shipping 2020 summary and forward projection. So let's say good morning or good afternoon to Jad Mouawad, who is going to talk first on scrubber technology. So welcome to you, Jad.
Thank you very much, and good morning to all. As mentioned, I will speak on two different topics today. Both are quite important topics. My background is I've worked on cargo systems on tankers before I started with ballast water management, and I'm also working with the environmental group in DNV, so dealing with this topic. I've put a small recap on what Trond has mentioned about the regulations, very fast. A couple of slides on why we have this and what is coming up, and also the technologies related to scrubbing, the solutions that are there, and a bit more technical, how does a scrubber work, where is it in the development phase, and what we see as issues or challenges that needs to be addressed as class from our side. On the regulation part, I think Trond talked about the same slides, the regulations coming in 2015 in the ECAs and 2020 or 25 worldwide on the SOx emissions. These are the ECAs today in the US, in the North Sea, in the Baltic, and possible future ECAs in the here in the Mexico, the Mediterranean, and also in the Norwegian shelf, Asia, and Japan. This is a very quick why we are talking about this one. This is the main topic that I want to discuss. As Trond mentioned, you have three solutions to reduce the emissions of sulfur oxides. LNG is a solution, low sulfur fuel is a solution. This is what you probably are using when you're calling European ports. They're doing this switch to the LSF. Scrubbers is another technology. MARPOL, Annex 6 is what's regulating air pollution from the IMO. It says that the fuel has to have a certain content of sulfur. At the same time, it says that you can find other methods to reduce the emissions of sulfur to the air. One of those methods is that is approved, because those methods must be approved by the IMO. We cannot come up with a technology saying that we want to, let's say, scrub the fuel. If you want to scrub the fuel, you have to go to the IMO, propose it as a method of solution. IMO has to say, yeah, this is a good solution. We amend MARPOL, and then we put it as a solution. The solution that is today most widely approved and discussed are the scrubbers. The systems must reduce the emission of sulfur compared to how much power they have, the engines. And there is a table that is set up by the IMO on how much sulfur you can produce compared to CO2 on percentage of volume. So the systems that you probably will be buying in the future, or the systems that are developed, have to prove that they can meet those requirements. And if we come to the end requirement of 0.1% of sulfur in the fuel, then you have to achieve this coefficient. And this is quite tough, but this is what the scrubber manufacturers are striving to achieve today. I'm saying that striving to achieve because, as we will see later on, I will give some examples on scrubber installations and developments. They are still under development. They are still quite on an early stage. Scrubbing is, for those of you that are operating tankers, you use the same technology on the inert gas system. You clean your exhaust gas. It's the exact same technology, nothing special. You run the gas through the water, you clean it from the sulfur, and you can actually remove up to 90% of the sulfur from the exhaust. A major issue that we have to consider is the waste stream. On inert gas systems, I still recall from the days I worked with tankers that there was a general agreement to not look at the waste stream from inert gas systems. It was too small, and we didn't have other solutions from explosions on tankers. So we had to have inert gas systems, so we just had them. When we put this on scrubbers of main engines and auxiliary engines, the volumes become extremely high. And that's something we have to keep in mind when we look at the scrubbers. Are we taking the sulfur from the air and putting it in the sea? Is it doing it a better work? Is it less pollutant or not? Important question. I will go through the systems that are in the market today, the technologies that are being developed. The open loop system is probably the closest one to what we have today on inert gas systems. And this is just taking the water in, scrubbing the gas, and discharging back. Hamworthy have a system installed on the Whole America ship. This is a main engine, 21 MW engine. They've also installed a new one on the Diamant ship. This new installation actually has a type approval certificate from DNV, so they are moving quite fast on their test. But still, those are test installations. They're not commercials. Closed loop systems. This is where you use fresh water, so you don't have to discharge the water to the sea. In order to absorb sulfur from the fuel, from the exhaust, you have to add alkalines. Wärtsilä is developing such a system. They have a prototype installed on the Sula ship. When you need to put all these alkalines, you have to make additional tanks for those holding tanks. You have to make a pumping system of this. You have to inject it. I will come back a little bit on the logistics of those installations. It can be quite some work. Another system that's coming up is Clean Marine Vortex. It's a kind of a hybrid system. It uses a cyclone to mix the water better. A cyclone is a very simple mechanical device that rotates the water down like a tornado in a way. So you get a very good mixture of water and exhaust gas, because this is the clue. The more you mix them, the better separation of sulfur you have. They need some work for the particulate matters, because you cannot discharge this in either. So they have a trapping mechanism, a kind of a filter for that. They have a test installation as well, trying it. Dry scrubbers, another technology. It's a kind of, it's an absorber that absorbs the gas. It's a lot of chemistry there. And so, so far, they have a test installation. We haven't seen any results yet. How is this working? But just to give an example, that there are water solutions, but there are also dry scrubbers also available. or at least being developed. The last one is a technology, they call it CS NOx, trying to remove everything. They have a test installation on a ship, I think today. They want to remove both SOx and NOx and CO2 and particulate matters by doing some electromagnetic work on the water. A major challenge of those technologies, it's very good ideas, but one thing is to test it in a lab and have the chemistry and the paperwork. Another thing is to put it on a ship with a huge main engine and scrubbing all this. So it will be a lot of R&D to get to where these guys want to come. Again, as mentioned in my comment earlier, those technologies are, all of them, as we have seen, all those examples are still they're still being tested. Only the requirements are coming into force very fast. So the major question now is, will they manage to get there before your ships are required to comply with the new SOx requirements? This is the most important question. This is just a simple sketch on how scrubbing works. You just let the water in, you mix it with the gas, you leave it out. There are some makers who will filter the SOx from the water before discharging it to make it more feasible, toxic-wise. And the sludge have to be then discharged. This is a basic principle of a scrubber. Lots of installations. I've put this slide just to show you some pictures of those test installations. This is the old Borg system. Yeah. I guess anyone who has done at least some look at stability and naval architecture, you see that putting such a huge thing on the top of a funnel is a major weight. Putting it on the top of the ship, you're playing with the stability of the ship very, very much, and so it's a major challenge. It's heavy equipment, it's big, and it's put really high up on the ship. That could be a problem. These are, I'm not going to go through these, but these are the schemes of approval. And I think what's most important, the way these regulations are being developed for scrubbers, is that there will be some continuous monitoring of the outcome of these technologies. You can either monitor the operational conditions, pressure before and after the scrubber, the water flow, and as long as it is according to what is approved, then your system is good. Or you can actually monitor the SOx and the CO2 emissions and see if the percentage is according to the regulations or not. And this continuous monitoring it is possible. And I guess this is how it will be developed when you start implementing this. Water discharge criteria, again, toxicity, very important. I think I've worked a lot with ballast water systems, and the way they have developed, we should not come into a solution where 10 years or 20 years from now we discover that we're making it worse than it actually was. Discharging toxic water to the sea. I think we have to take care of this problem already now and find out, is this a feasible and acceptable solution or not in the very long term? This is important. Do proper work already now so we avoid, it's a typical recurring problem. We solve one thing, we create another problem, and I think we should avoid that. There are lots of manuals that you then should expect to have on board in addition to everything else. Record books, of course. Those manuals, again, we go back to training of the crew and all of these things that will come up. You will get a certificate at the end on the IPP when this is done, saying that your ship actually now complies with the MARPOL Annex 6 requirements when they come. It will be, we will monitor that during surveys every year and on the intermediate surveys, do the complete check of the scrubber at the end. And so it will follow the standard verification scheme of class. There are 2 test installations that we are working closely with. We've done some approval in principles for Wärtsilä systems and the Clean Marine system. Those are engineering pre-installation approval. So that I think what's most important for us is the safety of the ship. You don't create so much back pressure on the exhaust that you jeopardize the operation of the main engine, the stability, and all these things that can be a showstopper. We've done 2 projects as approval in principles. We have certified the Hamworthy system for the Jolly Diamant ship according to the guidelines for MEPC. So we have done some work, but still very few projects, very few. We don't have any fully approved compliant ship yet with the SOx regulations and the scrubber. We don't have that. I think the only ships that manage those are the LNG ships we have today, where we have issued certificates. We have not issued any class or statutory certificates, both for a ship and then fully certified with a scrubber. Major issues to be looked at: space, of course. These are quite huge, and the examples I've shown you are just for the auxiliary engines. So you'd probably have to times 10 to put it on the main engine. So it's quite considerable. Space also includes pipes. Those pipes can be quite significant. It's always underestimated, and then always go to the yard, and we don't have a place to put those pipes. Stability, as mentioned. The engines must be able to still operate within the manufacturer's operational range when they have the back pressure because of the scrubber. Because when you are sending the exhaust out of the engine and you are scrubbing it, you are stopping the stream at some point. And then this will create some pressure on the engine itself. And it should not be such that the engine is operating outside what the maker has delivered. This is important. Power, of course, needs a lot of power to do that. And then we come to the major issue, redundancy of active components. And by those, we mean pumps, valves, bypasses. For DNV, it's important that if this seawater pump stops working, you don't have to shut down the main engine. So that safety is always maintained when you operate the scrubber. We do not ask for 2 scrubbers so that if one stops, you put the other one. It's an impossible scenario. But the auxiliary supporting, like a pump and like a valves that always fail, those we require redundancy on them. And that's it. That's what I had to do on scrubbers. Thank you.